G'day guys, Jace here from Flying with Jace. Seeing as we're in lockdown, there's no flying going on. I thought we'd do a few videos on some of the things that start you off on your very basic or very first navigation lessons. Things that you might not know or things that you might just find handy. Now, yes, I know, everyone has a tablet, and I'll start the story off. Everyone has one of these. Everyone does their flight planning on there. Everyone uses that for everything. They don't always work. They have a tendency to go flat. And hey, we just need to learn to do it the traditional, good old-fashioned way. So that's enough said about the tablet. Let's not see that one ever again. A few tools, a few things I've found handy to learn or to use over the years. If you're using a World Aeronautical Chart or any of your maps and you've had them laminated or you've covered them with contact or something shiny like that, the best pen I've found to write on them with is the good old-fashioned Chinograph pencil. Look at me shake. Is the good old-fashioned Chinograph pencil or grease pencil or wax pencil or whatever you've been told to call them. You can write on your stuff, you can draw your circles, you can say up is that way. At the end of the day, if it's done with a talc or with a laminate, piece of tissue, plenty of that around, everyone's got heaps of toilet paper now, it just rubs straight off. Leaves your map good as new. So Chinograph pencil is a really good way to go. I've seen erasable pens. I've seen a few other things over the years. Chinos are great. Only a word of warning with those, don't leave them on the dash of your aircraft in the sun because the wax melts and you end up with a bent pen or all the wax running out. All right, when you're using paper maps or something else like that, I've found the 6B pencil. They can be a little bit hard to get onto, but they're a really nice soft lead. They're quite dark, they're quite wide, colour's good, incredibly easy to rub out. So go to 6B pencil rather than a HB or something. Also, the lead's a little bit softer. You don't find it poking through your maps quite as much. 6B pencil. All right, and everyone's got a mechanical pencil for taking notes or being accurate. Let's have a quick look at our map. I've just got a World Aeronautical Chart here. Standard 1 is to 1 million. I picked the first one that came to mind. I think it's the Greater Sydney one. We'll look at a flight from Bathurst to Parkes, just because we can. So how are we going to measure our track, which is our line across the ground, and also how are we going to work out what heading or what changes to put in to allow for any wind? All right, well, the first things first, we need to draw a line. Now, we need to remember when we're drawing that line, we're not going from the town of Bathurst to the town of Parkes. We're actually going from the airstrip. So see that little symbol there? That's an airstrip. In that case, it's a sealed one. You may find other smaller strips around, like Cudell here. That's got a dashed circle. But we're going from, and it's important that we draw our lines from, the airstrip to the airstrip. All right, we'll get out our Jeppesen plotter. So a few companies make these. They're a handy bit of kit. Okay, nautical miles, rulers along the edges. This one does 1 is to 500,000, which is your VNCs. 1 is to 1 million, which is your World Aeronautical Chart. And in the middle, 1 is to 250,000, which is your VTC. Obviously, it's important to know which map you're using and the scale of the map that you're using. All right, so let's draw our line from the Parkes airfield to the Bathurst airfield, or from the Bathurst airfield to the Parkes airfield if you prefer. Nice straight line. A little bit thick there. My Chino's actually gone a bit blunt. Okay, we've drawn it from the airfield to the airfield. How are we going to work out our direct track? Well, there's two ways we can do it. One, we can use our Jeppesen plotter, just like we were just looking at. Put that under the camera. Put it along our track. Little spinny bit at the top here. Okay, you align that. In this case here, I'll just slide it along the track till I align that with the 149 degree easting. And you read off here your track. In that case, I read 285. I'll bring that up for a closer look. 285 true, because remember, these maps are true. Now, if you don't understand the difference between true north and magnetic north, there'll be another discussion on that later. Otherwise, go and have a Google and learn the difference between true north and magnetic north. Now let's assume the magnetic variation around here is about 10 degrees. So we've said 285. So that would be magnetic variation of -10, variation east, magnetic least, 275. And I'm just going to write that in our little thing here so that we don't forget. Our track, 275. The other way we could have worked out our track is to use this beauty device, the Douglas Protractor. You don't see these too much anymore, but they're out there. These are also very handy in flight for doing diversions, and I'll show you that in just a minute. What we do with our Douglas Protractor is we put it on our departure aerodrome, in that case Bathurst, line it up with as best we can with either a northing or an easting, and that's pretty close there now. And you either read the track off there, or as I've done on mine, a U-butte piece of string, stretch it to your destination, read your track off here. Again, that's 285. Now, where this comes in really, really handy in flight is if you need to do a diversion, if you're flying along and you find yourself over the top of Canawindra and I want to divert to Dubbo, well, you know, I can look at that, or I can put this down. It's fairly easy to do in flight, right over the top of my position. Straight up there, I can tell you straight away the track there is 357, let's take off 10, 347 degrees. Job's done. So that's a really handy bit of kit to use in flight. I don't care which one of those you use to measure your tracks on the map. I prefer this one, but that's just as good. All right, so we've got our track. How do we get our distance? That's a really simple measure. That's a really simple job. Make sure you're using the correct scale here. So we want to use the one indicated as World Aeronautical Chart, okay, which is the inner one. And we want to make sure it says nautical miles. Some of these, if you get them from the States, actually have statute miles on one side and nautical miles on the other. And this one you'll see here is an example. It has statute miles on that side and nautical miles on that side. So make sure you're using the correct measure. Doesn't matter what one you use, as long as you're consistent, I guess. Line up 0 on 0. And yes, I'm teaching you how to use a ruler. That is 36.5 miles. Near enough to 37 miles. So our distance, 37 miles. That's the basics of the info we've already started to fill out into our flight plan now. If it was a no-wind day, we'd just truck along from our point to our point, hold our heading of 275, and we could reasonably expect to get there after 37 miles. There's never no wind. We need to accurately work out what the wind is at our altitude. We'd get that off our Met charts, and be able to use our tools to determine what heading we would need to make sure we fly that. Because as you can imagine, if our wind is blowing along here, we got wind blowing that way, and we just hold 275. As we fly along, the wind is going to blow us. It's going to blow, it's going to blow, and it's going to blow. We'll end up, depending on our speed, flying, being blown to the south by that wind there. So we're going to need to cock our aircraft into the wind and fly along into wind. Okay? How much into wind? It's going to depend on how fast we're going, but it's also going to depend on how strong the wind is. We've got a U-butte tool that we can use to work that out. Again, I'll get my 6B pencil and I'll get my sliding rule. All right, follow me through on this one if you've got one, because it's going to take a little while to get it right. The first thing we want to do is set our true airspeed. We will have previously worked that out using our true airspeed charts. We may know, you may have been given by your flying school a planning true airspeed. I always use, for the aircraft we're using right now, we're going to use 100 knots. So we set our TAS against 100 knots, or 10 is 100 knots, just so we've got it all set up. Then we want to set the wind direction into then we want to plot the wind direction on here. So let's plot the wind direction. Let's use our wind we've drawn in here. Let's say that's 10, 20, 30 knots from, what do you reckon, a little bit right of north. So let's go 005. Let's go 005 at 30 knots, just for planning purposes. So we take this inner slidey bit And let's assume that 005 is magnetic. So we've done our variation from our forecast. We put 005 up against this top line, or this TC pointer. I have no idea what TC stands for. Someone will be able to tell me. We line that up there. Okay, then we count up here till we get to our wind speed, 10, 20, 30 knots. Now, you can put a dot there if you like. I always lose the dot. What I tend to do is put a circle around it like that, and then put the dot like that. Okay, so we have a dot and a circle, 005 at 30 knots. Let's put our heading in. We knew our heading was 275. So now we need to know, now we put our heading in. If we go our 275 onto here, okay, so we continue to turn this around till 275 is lined up on our TC line. We can see from that the wind is way out here to the right, okay? And we can see that we've got 30 knots of wind from the right. We knew that by looking at that. So using that example there, we've got 30 knots of exactly right crosswind on our heading of 275. How much do I need to do that and aim into that wind to allow for that 30 knots of crosswind? Well, the answer is really simple. We look around the outside, okay, until we get to 30 knots. That will tell me I need to aim right 17 degrees. My 30 knots lines up with 17 degrees. So I would need to turn right 17 degrees into that. So what does that make it? That makes it 3. That makes it 275. 3, plus 17. That's 12. That's 1, 7, 8, 9, 292. So I would need to steer a heading of 292 to make that work. Does that make sense? Okay, let's try it with something a little bit more. And because our wind is directly out to our right, it's not going to affect our forward speed. It's not going to give us a tailwind. It's not going to give us a headwind. It's all crosswind. Yes, because we're cocked off a little bit into the wind, we're not flying straight along that line. So we are going to lose some of our ground speed. But that amount is going to be minuscule. It's going to be 1 or 2 degrees. So it's not really anything we need to worry about for this case. Let's look at a slightly different wind, so it's going to have a slightly different effect on us. Let's go with a wind of, what do you reckon, north, east. Let's go with a wind of about 030 at about 20 knots. Let's look at that. Let's look at what effect a wind from 030 at 20 knots is going to have on our flight. So we go back to our whiz wheel again. Make sure we've rubbed off our previous one. As we did before, we've set 030 at the top here for our wind. Make sure we're still lined up on 100 knots. Set 030 at 20 knots, which is there inside the circle. There's a dot. Put our course. We've still got 275 as our course. Put 275 in as our course. Okay, now we've got from this 18 knots of right crosswind. Just counting out here, there's 20, 18 knots of right crosswind and 10 knots of tailwind. So if we're relying on a true airspeed of 100 knots, that 10 knots of tailwind is going to give us a ground speed of 110 knots. Okay, and we've said we've got 18 knots of crosswind. We go around here to 18. That's about 10 degrees. 10 degrees. We need to aim 10 degrees into that to counter our 18 knots of crosswind. 10 degrees to the right, let's say 275, let's say 285. So on that track, we would need to hold 285 to fly from Bathurst to Parkes. Everyone with me so far? All right, next bit. How long is that going to take? to fly that? Well, it just so happens we have a side A to our slide rule. Mine's getting a bit old. It's getting a bit faded. You can't really see through it, but that's okay. We're not going to worry too much about all this flash stuff in the middle here. If you're flying a jet that has to deal with things like Mach number, okay, or if you're flying an aircraft that's operating in flight levels, chances are you'll have an electronic one of these, or you'll have something to work it out electrically. So let's just leave this for our simple little 100-knot TechNams that we're flying for our benefit. Okay, so we can set this up, and the way it always works, these numbers inside here, okay, they relate to your time, and it's handy, it says time, okay, and 1 hour, 1 minute, or 0, okay, so that lines up nicely. The figures on the outside, these figures on the outside, use those for distance. So if we go to our little plan here, we've got 110 knots. If we set in 1 hour, we'll do 110 miles. Now, that could be 110 kilometres, it could be 110 feet, it could be 110 whatevers, but we're working in miles here. So we set in 1 hour, if a ground speed of 110 miles an hour, in 1 hour we're going to do 110 miles. How long is it going to take us to fly our 37 miles that we measured between Bathurst and Parkes? Well, that's really simple. In 1 hour we flew 110. In 37, or to go 37 miles, 35, 36, 37, that's going to take us 21 minutes. How easy was that? 21 minutes. So we can say 37 miles. Our estimated time interval is, what did we say? Because I was talking too much, 21 minutes. So we've now worked out what heading to steer and how long it's going to take us to go from Bathurst to Parkes. I haven't allowed any for climb, and obviously if you're climbing, it's going to take a little bit longer than 21 minutes because you're not flying straight and level. You're probably not climbing at your cruising speed. I like to add a minute for every 2,000 feet you climb. So if you're climbing by 4,000 feet, add 2 minutes to that figure. All right, but we're working on just the straight and level. So that's how we've worked out our distances there. We can use that another way. We can use this another way. Let's say we've set off on our flight and we're quite happily flying along, and as we go past orange, we notice, we look at our clock and we say it's right on the hour. 00 is the minute we flew past orange. We're flying along and holding 285 is working really, really, really well for us. And we're flying along, and as we go past Manildra, there, we notice that we're just a little bit off track, but that's fine. But the time is 10 minutes past the hour. What time are we going to get to Parkes? Because we've worked out how long it's going to take. Well, we're going to whip out our handy dandy measuring tool here. Make sure we're using the nautical mile side because this is in nautical miles. Make sure we're using the WAC column because this is a WAC chart. And we're going to measure the distance. The distance between those 2 points there, 21 miles. So we did 21 miles in 10 minutes. How fast were we going? Well, it just so happens if we use this and we go to 21 miles and we say that took us 10 minutes on the minute scale, okay, if we did 21 miles in 10 minutes, in 1 hour, we would do 126 knots. 126 miles in an hour. So we're doing 126 knots. If we assume that we're doing 126 knots, that's quite a bit faster than what we'd planned at 110. How far have we got to go to Parkes? Let's just measure that really, really quickly using our ruler from our point there to the Parkes runway. We've got 23 miles to go. At our airspeed, if we leave it set up as we had it before, we go 23 miles. Miles is on the outer scale, 1 to 23 miles. It's going to take another 11 minutes to get there. So if we were over there at 10 minutes past the hour, we're going to be over there 21 minutes past the hour. So if we hold our heading, 21 minutes past the hour, we'll be overhead Parkes. That's pretty much what I wanted to cover, the basics of navigation and basics of navigation planning. Please feel free to ask any questions, leave comments. It's all good fun. I hope that wasn't too confusing. And, yeah, keep flying.